Welcome back. We will continue with the cable lecture. You see so we are discussing about, so in this lecture we will talk about all these things, but at the same time we will see what is cable construction. So let me just select the pen. So let me select the So cable construction. We will talk about how the cable is constructed. What are the different architecture of the cable construction? This is the important thing. Then we will do some derivations of the electric field. Then we will show you some of the cables, cross section cables. So these are some of the ideas in this. So you can see, so we will not discuss much about signal cables in this lecture. So you can say that. So we will mainly focus on this construction characteristics. So you can see the power cables. You see, if you look at the power cable, one of the power cables, you can see how many layers it has. Apart from conductor, layer 1, layer 2, layer 3, you can see, keep on seeing. So how the cable is constructed. As I said initially, the first and foremost thing is electricity. Actually, safety. Safety cannot be compromised at any cost. Then it has to carry electricity. Then it has to be mechanically strong. It should be resistant to chemicals, it should be resistant to fire. That means, there are cable materials which if the fire is there, it will automatically extinguish. So these are all designed as per very strict standards, strict guidelines. If you are going to install cables in a mine, you have to follow the strict standards, worldwide standards. And you can see here there is a cross section of a particular cable, cross section, as you can see. So let us look at this. What are the different things you have? There is something called screening. Okay, so screening of the cable. So this is uniform radial electric field. That means, there has to be a electric fields are, these are all having high voltage. This is high voltage. So that means, the electric field gradient, that means with respect, and this is earth is 0 voltage. So there is a voltage difference between this part and the earth, ground, high voltage. Everything is grounded in mining system. So this is high voltage. So this is called, if you divide the distance, there is a electric field gradient. So electric field is essentially the voltage gradient with respect to distance, dou v by dou x, you can see. This is called electric field gradient. That means, voltage by distance, differential voltage. So this electric field is essential for creating all kinds of damages. Electric field, this is called breakdown. Electric field is responsible for breakdown. That means, the earth's breakdown capacity is like 33 kV per centimeter. This is an electric field. kV is not electric field, kV per centimeter is electric field. So this is responsible for breakdown. So therefore, to reduce this, we have all these insulations. So to reduce this electric field, we put dielectrics. Because of this dielectric, there is a Gaussian law. Gauss law tells you the electric field is divided by dielectric. If the dielectric strength is increased, the electric field reduces. So this is what. So there are screening. The screening is responsible. You can see one screening here, copper screening. There are aluminum clad. These are steel. These are for armored steel. So you can see here the copper conductor. Then this is screen. Third layer is screen. As you can see, third layer here. This is the layer 3. You can see here. This is the layer 3. So layer 3 is copper conductor, which is screen. The screen is responsible for terminating the electric field. It is like, electric field is going on the metal, it becomes 0, it becomes parallel, it reflects back, it cannot penetrate a metal, it will short circuit it. So this is called a conducting screen, this is where it is. Then comes metal sheath. So there is a metal sheath here, you can see here, there is a metal outer sheath. So there is a metal sheath, this metal sheath responsible for giving strength. Then armoring, again it basically prevents moisture prevention, it prevents moisture. So this screening does uniform radial electric field, prevents electrical stress concentration. That means, it does not get stressed anywhere. So it is uniform. Then metal sheath is primarily responsible for moisture. Once moisture gets into this, it will damage the insulation, because moisture is conductor. So once it damages insulation, the cable will fail. Once a cable fails, it is very expensive. First of all, where it will fail, you have to find out, it is difficult, and second is replacement of cable. Therefore, to prevent that, you actually put a metal sheath. So it can have a pressurized medium, that means you can also put a coolant there, but it is not now, we will not discuss about. and then armoring is here. So, this armoring you can see here is armoring, here is armoring. So, this armoring provides mechanical protection and protects against impact and crosses. For example, the external armoring here, it will protect against impact. If there is a impact outer side, you basically prevent it. Then corrosion protection. So, you can see there is a metallic layer, protected metal layer also, it does not allow corrosion. So, if there is a metal which is has to be corrosion. So, there are layers, rubber layers, which then there are heat removal systems, pipes and ducts for heat dissipation for high current cables. So, that can be inside, there can be pipes and ducts here inside which will be like coolant. Then screening we have done, shielding, maintenance uniform, and there is a metal sheath outside. So, there are different levels of armoring, you can see here different levels. So, there is a corrugated aluminum sheet here, the outer sheath, corrugated aluminum. So, there are lots of levels of armoring. So, this is essentially the construction of a cable, and these copper conductors are stranded. This stranding is because of reducing the eddy currents because of the conductors. So, unless you strand it, the metal body, if you make it full metal body and the AC current is passing, there will be flux patterns and there will be heating. So, the stranding prevents that. Stranding also increases the mechanical strength. So, this is the additional components in the power cables. Now, if you go other than the conductor, these are all the additional conductors 1, 2, 3, 4, 5, 6, 7, 8, these are different. So, metal, then some rubber material, again metal, rubber material, again metal, like that. So, then you can see the same thing here repeated, the conductor insulation jacket basically. So, this higher voltage stronger electric field, because of the shielding, the electric field is minimized, all right. So, insulation decides the breakdown, all right. So, I think you got it right now. So, this is a cable construction. If there is a questions on this, you should be able to give a complete layout and why it is there. For example, why there is a external conductor here, it is further shielding. There is another conductor, this conductor is shielding also, prevents moisture to enter. Then there is again armor, why it is there, then all these things, jackets are there, you should be able to do it. So, if you continue for other 3 phase cables, for example, here is a cable where are many phases are there, 3 phase, possibly 4 phases, one can be fourth wire can be neutral. So, here you see every cable is insulated from the other cable, but these are generally low voltage cables. High voltage cables cannot have 3 phase like this. These are low voltage, means medium voltage, not like 440 volt, it can be a few kV, 3.3 kV, etc. So, these are all the 3 phases together, fourth wire is for neutral, it may be, all right. Now, let us get into the electric field part of the how it is derived. Electrical field at a radial distance, this is the conductor which is having higher voltage, and outside is earth which is having ground voltage. Remember, the one of the system is grounded, therefore, voltage is always computed from the conductor to ground. So, this is the radius diameter. So, there is a potential gradient, how it is done you can see. R is the radius of insulation, RC is the conductor radius, this is the conductor radius, you can see this is the conductor radius, and R is the radius of the A. Then small r is the distance, at any place the electric field looks like this, V is by R by into ln R by capital RC. So, how it is done, we can derive this. Let us make this exercise of deriving. Let us do a geometry of, consider a single core cable with conductor radius A, inner radius of sheath is B. It is like this. This is the conductor radius which is A, and there is just a concentric, and this is insulating material. This thing is insulating material. These are all insulating material. But this is conductor. This is conductor. Let me just do little bit of more color thing. So, this is conductor. This is your conductor, this yellow portion, okay, having small radius, conductor is A, and the outer radius is B. Let us have this. We are not getting into very complicated things, we will make it, keep it simple. So, this radius is B, this is A. Okay. So, dielectric strength is epsilon here. Conductor dielectric strength is epsilon 0, always remember. Conductor, any conductor, the dielectric strength is equivalent to the vacuum, almost same, copper. So, we have to find out the electric field between this and this. What is the electric field? A and B. With insulate, E epsilon is the epsilon is equal to epsilon 0 into epsilon r. Epsilon r is the relative permittivity. So, r is the distance from the cable center. So, distance from the cable center, that means the distance between here and here, not here. So, this derivation we will do, we will not do other derivations, we will only do this. So, what is the principle of electric field? It is all radial, therefore, this is the unit vector in the radial direction. So, E is a function of r and the direction is r cap. R cap is the unity vector in the direction of radius. Radial direction outwards. So, Gauss law tells you the total enclosed charge divided by epsilon is equal to, so Gauss law tells you d is the flux density and the area, if you integrate over the closed surface, it will be equal to the total charge enclosed, and d you know. So, this is called closed surface integral. So, d you know is same thing as epsilon into E. So, putting this in the Gauss law, so that means if it is E into E dot dA, then it will become closed surface is equal to Q enclosed by epsilon. So, therefore, so this cable, let us say the charge density is lambda coulomb per meter. If you consider a length L, you know, in the length L, so the total surface area is twice pi r into the L, because I am considering a length L. So, this is the cable, this is the length L. So, in the length L you can see this length L and this is radius is equal to r, any length r. So, twice pi r L is the total surface area multiply E r and lambda into L the total charge by epsilon. So, L cancel. So, this becomes now becomes the electric field because of the charge density lambda. So, this is clear. So, once this is lambda is called coulomb per meter, linear charge density, line charge density, because it is a cable. So, if you go there, then what is the voltage? Voltage between A and B, this voltage into A and B is the total voltage, because that is the voltage of this with respect to ground. You can see this voltage with respect to ground is voltage V, that is supply voltage. So, you just integrate. So, voltage in the conductor everywhere same V. So, therefore, integrate from A to B. So, this will give you the total voltage. So, that is what E r into d r. So, if you integrate, so E r you replace lambda by twice pi r. So, you do this all these things. So, this becomes voltage. Once this is the voltage, lambda is coming out in terms of the voltage. So, for electric field you put in place of lambda, you put this expression. So, you get E r is equal to ln V by A. This is the radial electric field in between the conductor output and outer, this is the conductor outer and the cable inner, you can see the cable inner. So, there are many sheaths, we are not doing that. So, once you that, so the final expression comes out to be this is the final expression. So, where it will become maximum, that means r is changing. So, r if you keep on, so r is A is the internal, so minimum is at A. So, this is minimum. So, maximum stress will be when r is equal to A and minimum when r is equal to B. So, this is the maximum electric field, this is the minimum electric field, and if this electric field, minimum electric field, you know, has to be minimal, so that there is no breakdown, right. So, this is the maximum electric field. So, therefore, you have to put proper material shielding, you can say. So, if you look at the potential distribution of R, so you just do, because dou V by dou R is equal to electric field minus of electric field, you can say. This is the gradient in the radius direction. So, if you integrate this E of R dr from any R, so you can change the variables E x. So, between B is the outer in the sorry B is the I think B is inside radius, B is the outer radius. So, if outer is the 0, outer is at 0 potential, outer is at 0 potential, if you integrate R to B, so if you put into Ex etc., X and all these things, so this becomes your voltage. So, radial potential distribution looks like this. This is the radial potential at any point. R is equal to a voltage V, R is equal to B, it will be 0 or ground. So, that means electric field is not uniform, as you can see. The strongest is at the conductor and the near the insulation, therefore, most stressed. So, therefore, the maximum electric field or potential gradient occurs at the conductor here. So, therefore, here the breakdown is maximum chance. That means, at this point the maximum electric field or the maximum potential gradient. So, therefore, on this surface at that point there is a possibility of breakdown. All right. So, this is how insulation near the conductor is therefore most stressed. This is why cable design focuses strongly on conductor screen and insulation quality near the core. So, you have to be very careful near the core or where the insulation is touching the conductor inside. So, if you look at the cable, it is also having some like resistance, capacitance, inductance etc. So, what is the capacitance formula? Q by V, which is same thing as if Q is lambda L, you can say C dash capacitance per unity length, capacitance per unity length is equal to lambda by V. This is called C dash, and lambda is given like this. So, C dash turns out to be this. So, this is capacitance per unit length, and as long as B and A are all fixed, as capacitance is also fixed. So, therefore, you have to be very careful about choosing A and B, also epsilon, to take care of the capacitance. So, these are some of the important formulas. That means, if there is a cable with a concentric conductor here and there is a insulation outside, and this is A radius A and this is radius B. So, this is the and any distance r, this is the potential gradient or electric field, maximum at the surface which is here, minimum at the here which is here, and potential at any point will be this, and the capacitance per unit length is this. So, this is the summary of what we just did. So, look at electric field not only the case, there is magnetic field also. Whenever there is current for cable, electric field is important because of the insulation failure. Magnetic field is not so much important because it does not create much of the interference, but still we should consider that. So, electric field is distorted in a 3-core cable and it is radial. In a 3-core cable, because of the aspect of 3 voltages, it is distorted and they are coupled. 3-phase cable in the sense which I said just now here, these are 3-phase cables or 4-phase cables, whatever, these are 3-phase, not this, there are 3-phase cables. Okay. So, in case of multi-phase cable, the electric field is distorted and coupled, and single core it is radial. In magnetic field it cancels each other because 3 currents they cancel each other. It is strong, that because of the outer conductor. Losses in a 3-core conductor is moderate, insulation stretch is non-uniform in case of 3-core cable. EMI, the electromagnetic interference, EMI stands for electromagnetic interference, electromagnetic EMI. So, there is moderate and there is nothing, a single core, because there is a outer. So, the screening of the cable is very important. This is called screening. So, why it is important? So, these are the screens, you see. Without screens the electrical field becomes non-uniform, but with screen it will become uniform. How? So, without screening the electric field becomes non-uniform, stress concentration occurs, partial discharge can occur. So, without screening means without any conducting coupling, but the moment you give screening, it will terminate on the conductor itself. So, the purpose is you have to do uniform radial electric field. It will reduce the insulation stress and it will improve reliability. So, these are typical screens. One is in conductor screen, semiconducting layer covers the conductor, then insulation screen, that is conducting semiconducting layer over the insulation, metal screen, layer of conductive material, copper and aluminum. So, these are typical screens, the conductor screen, insulation screen and metal screen. So, these screens are put on this. So, either it is semiconducting or conducting. So, because of that the electric field gets terminated and it does not spread outside. So, this is called screening. So, if you look at a typical mining cable, you see this is what is the typical mining cable, and you know there is a 3-phase cable, as you can see this is a 3-phase cable. Let me change. This is a 3-phase cable. So, these are different types of cable arrangement. This is 3-phase, there are single phase, there are 2 conductors, perhaps return is also there. So, these are mining cables, and these are some of the codes which we use to identify the mining cables. Different times, like G contains uninsulated grounding conductors, common in low voltage AC systems, also used in DC. These are codes, simple code. W means without uninsulated grounding, that means used because there are so many variety of cables are used in mines. So, these codes are used. GC means insulated ground chain, you do not have to remember this, but these codes are used. SS means shielded cable, generally shielded, no specific note. D multiple insulation shields, D. C means single insulation shield, one shield around the cable, entire assembly jacket, each power conductor individually shielded, as you can see here. Then MP means mining power feeder, used for mining feeder applications. So, cable code is basically combination of grounding, shielding, monitoring features tailored for mining power applications. These are different ways to, these are the combination of grounding, shielding, monitoring features tailored for mining, safety, power delivery answers. So, the GW, GC they says about those things. So, if you go into more details, typical codes, W means 2, 3, 4 insulated power conductors, flat or ground cables. G means 2, 3 insulated grounding, uninsulated grounding. GC 3 insulated, 1 to ground, 1 ground check conductor. So, there is sometimes I forgot to mention, if conductor for ground check, constantly you have to see the cable at the other end grounded or not, because unless it is so you cannot really monitor the fault. If the cable is faulty, it should be connected to the ground so that there is no high voltage. If the cable is not grounded, there will be high voltage, and what will happen? You will get a shock, and there may be discharge, partial discharge and fire and all these things. So, then SHD means 3 shielded conductors, 2, 3 grounding conductors. SHC means 3 insulated conductors and the corresponding utility shielded around entire assembly. SHD GC 3 shielded conductors, 1 to grounding, 1 ground check. C means ground check, same thing. So, all these things, MPF 3 shielded conductor, 3 grounding. So, these are some of the things. So, the overall you can see grounding conductor provides fault current path, it is safety. Ground check conductors monitors ground continuity, it will detect the broken ground. If there is ground broken, it should monitor, otherwise there will be no safety. So, it will monitor G, GC will monitor G. Then shielded controls electric field and leakage, essentially for high voltage and EMI control. So, it is shielding. So, it is shielded cable. Multiples, D means each conductor is shielded, better insulation. C means one shield around the cable, simpler, lower cost, and mining power feeder means MFP means high power transmission cable used for long wall and heavy equipment. Or long wall, as I said earlier, that they are used for proper foundation in the surface. So, these are some of the design aspects. Portable cables, HSD or HSC, as you can see here, control electric field leakage, etc., flexibility and safety. Long wall mining, G, GC, GST, etc., continuous ground monitoring. High voltage feeder, MFP, MP, AGC, high reliability and shielding. DC system, no insulated ground needed. Safety critical zones, GC mandatory, detect ground failures instantly. So, based on this we will have some pictures, as you can see. So, this is type W, type G, as you can see, type GGC, type G plus GC. So, you can see, try to coordinate type G. So, this is type G, you can see what is type G, provides fault current path, as you can see type G, okay, uninsulated grounding. This is then type W. W is 2, 3, 4 insulated power conductor, flat or round cables. This is type W, you can see. Then type GGC. So, type G plus GC, you can see. So, this is all cables in one. You can also have type 2/C type W. Fillers may not be needed if conductor insulation fills the voids. Then different types, type 3C. So, there may be more conductors. Then you have type SSD, MPGC, type SHC, flat SC. So, these are the cross sectional views of the conductors. Then we have to go to the next is failure mechanisms. So, what are the different failure mechanisms of the mining cables? So, these are some of the mechanical things which is responsible for most of the failures. Mechanical abrasion, for example, here the abrasion is there constantly. Then tearing, this is constant abrasion. Then crushing, then fatigue means there is mechanical fatigue. So, these are some of the abrasion, tearing, crushing and fatigue. These are some of the major mechanical failures of the cables. So, mechanical cables. So, cables mostly fail because of this. It can be because of external agent or it can be because of itself. And there is wear and tear because of constant crushing, more load, movement, higher wear, etc. And there is wear concept which is because of movement and higher wear. You can see if there is movement, constantly movement of load, etc., there will be again. So, if you continue, you can see these are some of the abrasion, how it is constantly getting friction and therefore, this getting damaged. So, you can see it slowly gets teared, it is because of some reason it getting teared. Then it is crossed with a motor. So, it is also damaged. Fatigue, fatigue means it is for long time it is there. So, there is a mechanical fatigue. So, cable gets, this armor gets, outside cable armor, as you can see, it gets distorted and it fatigue, it breaks. So, all these breaks leads to potential cable failures. So, cable failures are because of this abrasion, tearing, mostly because of this. So, the cable handling. So, these are bulky cables. So, handling has to be very careful, otherwise there will be mechanical stress and there will be breaking of the cable, and these are very expensive cables. These are all armored cables, as you can see. So, what will happen that you have to have heavy bulky cables, manual handling, frequent exposure to harsh environments. Then high pulling force, stress concentration lead to internal strand damage. Once there is a strand damage, it will damage again there. So, what is the cable life? Continuous miner cable life is 8 months. For example, the drag line continuous miner, shuttle car 3 months. Frequent repair is required, as you can see. Typical life continuous miner is 8 months. Repeated bending, etc., is there in continuous miner. So, therefore, the cable life is, and therefore, you can imagine the kind of cable expenses in mines. And these are some of the things, tension, bending, twisting, how it is done. These are some of the simple mechanical things which you might have read already. And when you bend, cable has to be bended. When it has to bend, you have to properly choose the radius, otherwise cable will be damaged. The small bend radius and all. So, these are the cable reeling. When the cable reeling is layered winding, poor cooling. So, when the cable is reeled over, heat is generated and it is inside. Heat is not able to dissipate. There will be heat accumulation. Once the heat accumulation is there, there will be heating, and once there is heating, it leads to cable degradation, as you can see from these pictures. These are all generated for you. There is no copyright. These are all copyright pictures we have generated. So, you can see how, because this cable winding continuously happens continuous miners and shuttle cars. So, this is called cable reel effects. And cable whipping hazard, moment there is a cable behaves like elasticity, if there is a snapping of the cable, it will create huge damage, even death. So, the stored energy also released, suddenly there will be sparking, fire, etc. So, it has to be very carefully seized about the carefully connected without much stress, tension or those kind of stress. So, there will be also environmental degradation. So, that those are all because of mechanical thing, but there could be environmental degradation because water gets in, water droplets will fill in because the mines are wet, moisture reduces the resistance and shock risk increases because the moisture is a conductor. So, as you can see here, in most of the mines the underground water is there, though it is pumped out, but still water is always there and cable has to go inside the water. So, the conductors in mine cable. So, now we will talk about the conductors and insulations. So, we will do it next class.